a tripler here, and this is related to the shift stuff we were talking about in the lecture. So I'm going to create this triple one that ASM make clear. So nano triple one.asm. All right. Now I'm going to put in this code. All right. All right, so here's data. I've got a buffer in, which just has some blank space and a length, and then I got a buffer out, which has some blank space and a length. Okay, so I've just got some empty placeholders there to hold some things to print them out. And we'll see what we got here. I'm going to do a read from the user of the length of buff in, so I'll read some data from the keyboard. Then I'm going to double it by shifting left. I'm going to move it into AL, which is the lower 8 bits of the A register, shift it to the left one, and then add A1 to A1. And then I'm going to put that in buff out and print buff out. So I'm trying to triple it. We'll see how well this works. So I'm going to compile and load it. And to do that, I'm going to go back to ASM 100 and get the commands that do that. So to compile it, it's, there we go. There. So NASM minus F, I'll get out of here. NASM minus F, ELF 32, triple 1.asm. Okay, then I have to do LD minus M ELF I386, output into triple 1, and input into triple dot O. All right, now I should be able to run it. All right, and so if I give it 1, I get a question mark. That's not very good. If I give it a 5, I get a question mark. If I give it a 10, I get a question mark. So it's not doing a good job tripling things, is it? All right, so let's see what we got here. That's a bad triple. So I'm just getting unprintable garbage every time, and that's failing. So now, let's try triple 2 here. See if we can make more sense out of it. All right. All right. So once again, I have in and out, and I have something called print CS here. All right. And here, what it's going to do is the same thing as the previous one. It's going to read some data from the user. Then it's going to move something at AL. And it's going to keep calling print C after each one. So print C is here. That's going to print the character in AL. So it's going to print it as a character every time. So I'm going to be able to see how it's being interpreted every time. That's the idea. So let's save this. And it's triple 2. So I'll do this one, triple 2. And this one, triple 2. Oh, and I gotta plug in power. That's what that sound means. Okay. By the way, there isn't any power meter that I could download anywhere that worked on the Mac. I had to write my own bash script. It's ridiculous. There are no power meters that actually do anything useful. Ridiculous. Maybe I should sell it. Anyway, so now I can run it. Let's run triple 2. Okay, so if I give it a 1, okay, the original data is 1, but then it turns into a B, and then it turns into an unprintable character. So that's a little disturbing. All right, and if you want to understand why, let's look at the code here. It reads 1 from the user, and it gets that correct when it prints it. So AL does print as 1, but when I shift it to the left, the problem is I put in the ASCII character 1. That is not equal to the integer value 1. That's in fact equal to 31 in ASCII 48. So when I shift it 1 to the left, I'm not actually doubling the 1, I'm doubling the ASCII value 31, which will double to hex 62, which is another printable character. It's a B, but it's not at all what I wanted. What you have to do is read the single digit from the user, then subtract 48 from it, then triple it, then add 48 back to it if you want to get the number that triples it. That's what you have to do. You have to understand an ASCII value of the letter 1 is not equal to the number 1. And that's what's going on here. And if you read that tutorial, it'll help guide you through it. So you can make us something that will actually read data and translate it into hex and understand it, triple it, and do things like that. So there are various things you can do here where you input data and correctly convert the character data into the right number and then do math on it. So that's what I wanted to show you. And I think that's enough for today. Let me stop this.